In Rome, there were the Haruspex, powerful seers who searched inside of animals to predict the future. Today, through scientific principles, we have been able to determine how the story of life on Earth unfolded. Perhaps we can use these principles to predict the development of life in our future. Project Haruspex, to see the future inside of animals. Life on Earth started 600 million years ago. All organisms on Earth came to be because they changed over time. The unsuccessful die off, while the successful reproduce and pass on their traits. This is natural selection, and forms the basis of how Charles Darwin came up with his theory of evolution. I want to take you on a journey and explain how you can imagine new creatures using the rules of evolution. We call this speculative biology. In this video, we will follow 3 steps and show you what might be possible. We will find an environment which will inform change. Then, we select an existing animal that will evolve, and finish by telling you the story of our new species. Natural selection is driven by the pressures exerted by an environment on a population of organisms. Pressures such as food, climate, and even human influence can be the driving force of change. To understand how a certain environment will change an organism, we need to answer questions such as: what animals can be found in this environment, and what adaptations do these animals have? Take, for example, a salt lake. This environment is so salty that only brine shrimp and specialized algae inhabit these waters permanently. While microscopic, their presence can be seen in the beautiful pink color of the lake. They form the food source of the less permanent residents of this lake, flamingos. The famous rose color of flamingos comes from their diet of brine shrimp, which they eat via a method called filter feeding. Like the name suggests, filter feeders sift through water to eat the microorganisms that can be found in there. There is even a species of spoonbill that not only feeds on the same organisms, but also possesses the same rose hue as flamingos. Salt lakes can be found in Africa, South America, and India. Flamingo populations migrate to these salt lakes to nest. The exception of this being Australia, where the flamingo population went extinct around 140,000 years ago. Our creature will be a new branch on the tree of life, the origin of this branching being the ancestor of this creature. For the ancestor of our creature, we will pick a bat, specifically the little winged bat, or Miniopterus australis. To understand the context of this animal, we can look at the characteristics of other bats. Bats belong to the order Cryoptera. There are fruit-eating bats, blood-drinking vampire bats, and even nectar-drinking bats. Our species belongs to the family Miniopterus, which usually prey on insects, and they can be found in Southeast Asia and the Australian continent. Combining what we know about bats, filter feeders, and salt lakes, we can now create a story. In the future, increasing food demands and a lack of fresh water lead to the development of saltwater rice crops. The cultivation causes the large-scale creation of artificial salt lakes. Southeast Asia becomes familiar with the sight of rice paddies whose waters turn pink from salt-loving brine shrimp and algae. But even more surprising than the sight of pink rice paddies is the extremely quick adaptation of creatures to exploit these resources. The brine bats now sow in the pink rice fields as they feed on the abundance of food available to them. With a lack of competition, they evolve long jaws with bristle-like teeth. Their diet also means that they have an abundance of red pigment. The healthiest individuals are the brightest pink and the most likely to reproduce. Their range extends from the south of Japan to Australia, with populations migrating to warmer regions in accordance with the seasons. This is an example of how information forms the basis of speculative biology. Whether brine bats could develop is up for debate. Such debates are important to further the understanding of the natural world, as arguing about how fast something can adapt or how humans influence the course of nature deepens our knowledge, and with that we can shape a more informed future. Project Haruspex.